Maximum number of balloons. Given a string text, you want to use the characters of text to form as many instances of the word balloon as possible. You can use each character in text at most once. Return the maximum number of instances that can be formed. Okay. So given nalabolko, or the fuck this shit is, you can make balloon once if you can use each character once, right? So as you can see here, we can see BALLOON. That's balloon. Here we can make balloon twice in loon ballex paul poon. So we can make balloon twice here. In leetcode, however, no balloons in leetcode. We don't even have a B. Don't have two O's. I mean, you get the idea. It's pretty fucking obvious. What I'm trying to say. All right, so it's so if we want to code this, right? Here's how we can do it. Let's create a hash map, and we're gonna run through text. And for each element at text, inside text, we're gonna count how many instances of that element there are in text. And so the hash maps is basically gonna be a counter for each letter, pretty much here, right? Because it's a string for each letter. Just for so after we do that, our next loop is going to be going through a list of balloon, a list of characters balloon. So we'd have BALONN individually inside that list. And we're going to check how many times, what's the frequency of each of those letters inside of text, for each of those characters inside of text. Okay? But, however, you'll notice in balloon, there's two L's and there's two O's. So just for those two, we're going to divide the frequency of whatever we have by 2 floor operation. Yeah, because we had like 3 L's, we could still only make 1 balloon, right? Just think about that. And we're basically going to get the minimum number of the frequency, because let's say we had 5 B's, 5 A's, 10 L's, 10 O's, but we had only 1 N in some string X. Okay? We can still only make one instance of balloon. Only one instance of balloon can be formed because we only have 1 N. So we need the minimum frequency. Okay. Great. That's the algorithm. Let's code it out. Counter is oh wow. Default dict integer for I in text. We're gonna have counter of I plus equals to 1. Yeah, I always do make that same mistake. So max instance, we're gonna make it like, I guess, integer.inf at first, because we just want it to be a really high number. It doesn't really matter. Yeah, and then we're gonna have the array of those things that all the characters that we want to check for. Char array is gonna be equal to B A L O and N. So that's our character array. For Y in char array, what we're gonna do, we're gonna have a frequency. We're gonna get counter of Y. Simple. However, if if, right? If y is equal to L, or if y is equal to O, what we're going to do is we're going to have frequency is going to be equal to the counter of y. So I'm going to get the frequency of those L or O's. I'm going to divide that by 2. And we're going to have max inst is going to be equal to min. Guys, it's going to be min, right? Because we want the minimum count of, these are two different things, or concepts here. To get the maximum instances of balloon that can be made, we need the minimum frequency of the minimum frequency out of all of these characters inside of text. We need the minimum frequency of, yeah, so that's pretty much what we need to get the maximum instances of balloon is equal to, okay, so we're going to get the min of that and frequency, and then we just return max instances. That should be our solution. Oh, no, it has no, it's fine. We just make it a really high number, like something beyond this text length and a 4. Okay, so we can just do 1, 2, 3, 4, just add a 1. All right, so this is okay, so for I in text, since text is our input, this is the only array that we really care about. We don't care about this one. So yeah, for runtime complexity, it's just O of n. For extra space, however, I think extra space is O of 1, because we're not creating any new structures based off of the input text. And yeah, it's gonna be about it. All right, see ya.